All right. What's happening, y'all? So we're going to jump right into this. Today, we're going to be creating a VPC with Pulumi and Python. So let's just go ahead and get started. So we're going to go Pulumi new Python, and we're going to let this execute. All right. We're going to go ahead and say project name, VPC in Pulumi on AWS. We're going to leave the stack name as dev. We're going to go ahead and configure a secret key. This is very useful feature of Pulumi where you need to go ahead and put in a password to go ahead and deploy your infrastructure or have an environment, which means that if you have some build and deploy servers, you can go ahead and put an environment variable there, have it build and deploy, and it'll be password protected, another layer of security. We always like that good stuff. So we just had our project finished creating. We're gonna go ahead and open up our code editor. Let's get right into it. All right, we have our code editor open now. So let's go ahead and outline what we're gonna do to create it, what we're gonna go ahead and create it. So we're gonna import Pulumi underscore AWS as AWS. Well, actually, we're gonna say from. Let's go ahead and do a from. From Pulumi AWS import EC2. So let's go ahead and get our list of things to do. This is what we want to go ahead and create today. So we're going to create a VPC. We're going to create 3 subnets. We're going to create an internet gateway. We're going to create 2 route tables. We're going to go ahead and attach this internet gateway to the VPC, which, let me put this here. So we have an agenda, all right? Attach internet gateway to VPC, or associate is probably a better word. Awesome. So what we're gonna do after that, we're gonna create 2 route tables. We're gonna create a route to the internet in one of those route tables. We're gonna associate that route table with one of the subnets, which is gonna make it public. We're gonna create a NAT gateway. We're gonna create a route to the NAT gateway. We're gonna associate that with one of the secondary route table, and then we're going to effectively have our VPC with 2 private subnets that are allowed to communicate to the internet, but the internet can't communicate to them. And we have one private subnet where we can put a bastion server to talk with our instances in the private subnet. And this is going to be the baseline for our infrastructure or our company, B company. So let's get started. So first, we want to go ahead and make sure we install Pulumi AWS. So we're just going to run pip install Pulumi underscore AWS. And we understand that the VPC is in the EC2 package. So we're going to wait for this to set up really quickly. Alrighty, it's taking some time here, but it's okay. I'm gonna leave this full, so feel free to skip ahead to the different parts where we actually start creating the resources. I want to leave this as a full video with no cuts so that you get an understanding of what it would potentially take to do this in real time. So we have Pulumi AWS, so now we're gonna say BVPC, and we're going to equal that to EC2 VPC. And we have this autocorrect here, autocomplete. So we're just going to go ahead and put the name in here. So we're going to say BVPC, right? We could just say main VPC here, main VPC. This is the label that Pulumi is going to have. So we're going to do this main VPC. And now we want to go ahead and specify our CIDR block. So we're going to go ahead and use 10.0.0.0/16. You can use what's necessary for your particular workload. Next, we're going to go enable DNS hostname to true because we want the resources spun up inside of this VPC to have host names. And we're going to go ahead and enable DNS support equal to true as well. Now, this is I believe true by default. We're going to explicitly specify here. So now we have our VPC. Let's go ahead and create our 3 subnets. So we're going to call our first subnet public underscore subnet 1, right? We want to go ahead and prefix or suffix it with 1 because we want to leave room for future expansion should we need to put it in another availability zone. So we go ec2.subnet and we're going to say public subnet 1, and we're going to specify the CIDR block here, and this is going to be 10.0.0.0/24. It's going to give us 253 addresses. We have broadcast network, so it's 255 by default, broadcast network, and then we have 2 reserved, so 251. My apologies there. So we're going to have 251 available IP addresses here, and we actually want to go ahead and specify our availability zones. Now, when you go back, what you want to do is you want to parameterize this, but we know we're going to do US East, so we're going to do this in US East 1A. We know this is where it's going to be. There are ways to go ahead and get the availability zones inside of Pulumi. Just really quick, let's go ahead and do a quick detour and get these availability zones. Let's see. So inside of our VPC, we probably can say something like AZs equals B underscore VPC dot. Maybe that's not how we get them. Well, this is going to be a to-do item for you to look up, but there is a way to get all the availability zones in a particular area, so we want to go ahead and continue here. So we're going to put this in availability zone 1A, right? So we're going to do private subnet 1, and we're going to go ahead again to save time. We're going to go ahead and copy and paste this particular line, and we're going to leave this in 1A. And we're going to go ahead and just change the name here to private subnet. And CIDR block here is going to be 1/24, and we're going to leave this in 1A again. Now we're going to go ahead and create the second private subnet, and we're going to put this in 1B. Awesome. So now we have our 3 subnets. Let's go ahead and create our internet gateway. So we're going to say BIGW equals ec2.internet gateway, and we're going to go ahead and call this BIGW, or let's say main internet gateway. And we can see here, if you have VS Code, we have simple use, but we see here the required is the VPC ID. So we're going to go ahead and say VPC ID, and we're going to say B underscore VPC dot ID. Great. Now we should have this internet gateway attached in this way. So we can go ahead and remove this, and let's go ahead and create our route tables. So we're going to say public RT1, and we're going to set that equal to ec2.route table. And here we need to go ahead and specify the name. So we're going to say public RT1. And next we need to go ahead and specify some routes here. And so now we're going to go routes, and here we're going to create a EC2 route table route args. And in this route table route args, we're going to go ahead and specify a few things. You can see here, if we're doing the example here. So we see the route table, we have routes, right? And this should be, looks like a list of route table args. And we're going to specify a CIDR, which is going to be the ultimate destination. And we're going to specify a gateway for that destination. So in our case, it's going to be 0.0.0.0/0 for default route, or the default specification where all traffic should go if there's no other specific route. And we're going to specify the gateway of the internet gateway. So let's go ahead and do that now. So we're going to go ahead and right here on routes, we're going to go ahead and put this in a list. or an array rather. So in here, we're going to say our CIDR block, specify 0.0.0/0. And next, we're going to put our gateway ID as the b_igw.id. Awesome. So now we have a route table. And now we want to go ahead and create our private route table. So let's go ahead and say, whoops, let's go private RT1. And we're just going to say private route table. This is going to be for all of our private subnets. Well, let's say private application route table, because potentially we might want to do 3 layers where we have a database layer where the applications access the databases and it has specific routes there too. So we're going to go ahead and rename this to private_app_RT. And we're going to go ahead and move this create our NAT gateway up here. So we create our internet gateway, and we're going to say b NAT gateway equals ec2.NAT gateway, and we're going to go ahead and we need it here. So you see here it's connectivity private. We just need to connect it to a private subnet. So you can see here it gives us some examples. We actually probably want a public because we want this to be accessible via the internet. So we need an elastic IP first. So let's go ahead and create that. So we'll say create elastic IP. So we'll say b_NAT GW EIP equals ec2.elastic maybe it's EIP. There we go. So we're going to give this a name of NAT GW EIP. And here we can go ahead and see let's see here. We have some example uses here, but I'm going to go ahead and bring up the docs here because I want to make sure we're getting this all correct here. So I'm going to bring up the docs, and we're going to look for EIP here, and we're going to look for the required fields. So we're in the docs. We're going to go down to our inputs, and the address, that's optional, indicates if this is used in a VPC, which I think we want to go ahead and specify this. This is a string. Okay. So domain, we need to go ahead and specify here the domain. So let's go ahead and do that now. Okay, so we're going to go back to our code. So we need to go ahead and say domain equals b_VPC. And I believe we could, it needs to be a string, it looks like. So let's go ahead and vpc.id and see if that goes ahead and works for us. Okay, great. So we're going to call this the NAT gateway B, and we're going to go ahead and specify an allocation ID, and we're going to say b_NAT gateway _EIP dot allocation ID, and we're going to go ahead and specify a subnet ID. So we're going to say public subnet public subnet 1, and it looks like we need the ID here, so public subnet 1 ID, and we should be good there to go there. So let's go ahead, and we have our route table 1 with a route to the internet, so we can go ahead and do this here. We're gonna go and move this up here. Boom, bam, awesome. So we have a route to the internet. We have our private application route table, and we want to go ahead and make this gateway our B_NAT gateway. All right. So we've already associated this. So actually we haven't done that yet. So let's go ahead and say public RT assoc, and we'll say ec2.route table association. And we can see here an example usage. We want to go ahead and do a subnet ID and a route table. So we're going to go ahead and give this a name. We're going to say public route table soak, and we're going to go ahead and give it a subnet ID, and we're going to say public subnet1.id, and then we're going to say route table ID, and we're going to say public rt.id. All right, great. So we've associated that. Now we want to associate the private route tables as well. Associate private route. So we're going to go ahead and copy this. We're going to paste it twice. We're going to say private rt1, and now we're going to say private rt2, and let's go ahead and make sure these are different too, our labels. And now we're going to go private subnet1.id, and we're going to go ahead and say private route table application route table, and we're good. So now we already have our route to the NAT gateway. So great, we have a default route to the NAT gateway in our private route, and that's all. So now let's go ahead and see if we can get Pulumi up. And we're gonna do -y. We're gonna type our password. And we're gonna go ahead and let it deploy. All right, so it looks like the VPC ID is missing for our subnet. And that does make sense. So we need to go ahead and do VPC ID. So B_VPC.ID. And we're just gonna go ahead and copy this. And we're gonna go Pulumi up. We're gonna put in our password. And for our route tables, we're missing our VPC ID as well. So we're gonna paste that here in these route tables. We're gonna do it again. All right, we got our VPC creating. We have 13 resources, says it's gonna need to create. Expected domain to be one of VPC standard. Got VPC. Okay, so the domain actually just needs to be explicitly VPC. And we have a conflict here. We didn't change it after we copy and pasted. Shame on me. So we have 5 resources that got created here and 2 that failed. So we're going to go ahead and let it run one more time. All right. Looks like the NAT gateway is taking the longest to go ahead and create. You can go ahead and fast forward. This will probably take an additional 30 seconds. We will see here. In the meantime, I'm going to go ahead and bring up my account so that you can go ahead and see these resources have actually been created. But got him. All right. Yeah, you know, I got to throw some flavor on it real quick. You feel me? I'm trying to be understandable for you all so you can understand me, but we're going to keep it 1,000 while we like throwing a little pizzazz on it while we're waiting for this timer to count down. Now, I'm already in my account here. In my shared services account, I have an AWS organization, and we can see the VPC has been created. We have our subnets. We can go ahead and filter here. They have also been created. And you see in one of our subnets, the main one, we have 250 available addresses, and that is because we have a NAT gateway that has been deployed inside of that subnet, right? We see we have an internet gateway. And we go down to, let's go ahead and see if it's finished deploying yet. Not just yet. So we want to go ahead and check out our route tables. As you can see here, we have default right here. And we can actually get a nice visual representation of the resource map. And so you see here, we have this subnet here in 1A. This is our public subnet. Has a route to the internet gateway. And you see here, we have not done our route table association just yet for these last 2 subnets. And it looks like it's finished creating. So let's go ahead and refresh, and we should see a link to the NAT gateway at this point. So let's click our VPC. So let's click our resource map. And as you can see, we didn't associate this one correctly, it looks like. So you can see this particular subnet, which is in 1A, which is our private subnet, has a route. Let's go ahead and click here. And you can see 0.1 is 0.2. So we do want to rectify that. We want to make sure that right here is correct. We didn't change that for whatever reason. And let's go ahead and redeploy. It took 2 minutes and 22 seconds, which was relatively quick. Now you might be asking, well, this could have been a lot faster, right? This video is going on 23 minutes now, and take 23 minutes to create this for VPC. Now, just remember, you have this as your organization's default VPC configuration. So, should you want to deploy additional accounts, you can use this as a baseline and extend it as you need. Now, Python language allows you to go ahead and create other files, bring those files into the main file, and deploy those as separate modules. We're not going to go into that today, but as we continue on this journey, we will see that in practice. So, I just redeployed it, and we're going to go ahead and look at the resource map, and now we should see here we have it correct. So let's go ahead and look at this route table. Let's open it up. And as you can see, we have the NAT gateway. All the destination traffic is through this NAT gateway, and that's pretty much it. We have everything that we needed deployed. So we have this NAT gateway, we have a public IP address, so now we can reach the internet from any resources that we deploy inside of our private VPC or private subnets. Now, hopefully you learned something here. Hopefully this is insightful. Go ahead and leave a comment below. Let me know what you thought about the video. Hit the like button if you liked it and you'd like to see more of this content. Hit the dislike button if you thought this was trash and you want me to stop putting this out. So with all that being said, everyone, you have a wonderful day, and I'll see you in the next one. Peace.